Hi there guys, got a video here for you today on the FX DRS, and what we're going to be doing in this one is just showing you how I shortened the shroud and barrel of the rifle. So as you can see here, I've got it set up in the Sabre Tactical bronze chassis, and I think it looks really quite nice. I have ended up taking about 110mm off both the shroud and barrel, and I think it makes the rifle really look quite good. When we install a moderator on the end, that's just the standard FX mod, but with that installed, the rifle itself is now about 10mm longer than the standard one. But with that said, let's take you over to the lathe and we'll begin on the work. Right then, with that said and done, the first thing to do was to start work on the cylinder. We need to take 110mm off the end of this piece, and to remove most of the bulk material, we're just using a standard part-off bit, cutting just shy of my mark-out line. Once we've got the waste material removed, we can come back with a standard lathe tool and just face the end to final length. Once we've got that established, we can come back through with a micro boring bar and just put a small chamfer on the end, and this will act as a lead-in for the threads. Up next, we can use a boring bar to just remove some material from inside the cylinder. I'm just using a threading tool for this operation, as we only need to remove about 0.2mm worth of material, and we're just copying the original FX profile. This bore is stepped very slightly, with the diameter at the thread area being around 28.3mm, and a slight step for the O-ring to squeeze against being around 28.2mm. Again, we're just copying these dimensions from the FX part, and with that all established, we can start on the threading procedure. The thread that we're going to be putting in here is 29.3 by 1, so the major diameter of the threads is 29.3mm, and the pitch is 1mm. Not a standard thread, but luckily with metric it's nice and easy to make custom threads on the fly. The only tricky part about these threads is they don't have a defined end. There is no thread gutter for the threads to run in, so we do need to be fairly quick on the lathe handles, and we need to be nice and careful not to cut the threads too far into the cylinder. But with that said, here's just a quick shot of the lathe hand wheels and the DRO to show you what I have to do to get the threads right. Once I've got my cut depth set, I can turn the lathe on and wait till the top number hits 17mm, at which point I feed out with the cross slide hand wheel and at the same time power off the lathe. Then I need to just make sure that the lathe comes to a complete stop before putting it into reverse and pulling the tool out. To be honest, it looks a lot more complicated than it actually is. The key thing I need to do is try and feed out at the same point each and every time, and once we have them cut to depth, we can bring back over our end piece and get that screwed into the end to test the threads. As you can see there, we've got a nice fit between the two pieces of material. We want just a hair of play between the threads, not too much, not too little. Making the threads too tight will just cause us problems in the assembly process, and making them too loose could be dangerous. With the cylinder cut down to length, the next thing to do was to tackle the barrel. Now I'm going to be going nice and fast through the barrel process, as if you've watched my other video on the DRS showing how we machined the barrel up to fit, it's pretty much the exact same procedure. But whatever the case, the first thing to do was to mark out the length using our lathe tool nice and accurately, then come back through with a parting blade and just cut the waste off the end of the barrel. With that done, we can face the barrel to final length, then start working on the features for the transfer pull. We need to turn the end down for a thread. This thread will be used to screw on our brass transfer pulls. So we're turning the end of the barrel down, putting a nice thread gutter in the rear section of the threads and making a nice lead in to it. And once we've done that, we can come back over with our threading tool and put our thread on the end. Once I've done that, I can bring my brass transfer port that I made very quickly off camera over and then screw that onto the barrel. We can then work on the shank of the barrel, starting off by facing the end to length, then turning the OD of the shank down. The shank diameter on this particular barrel needs to be 10.5 millimeters. The next thing to do was put a small step on the front of the barrel to accept the magazine, and with that done we can start work on the internal features of the transfer port. Starting off with, we're going to be using a 4mm end mill just to create a nice round hole in the end of the barrel, and with that established we can come back through with a micro boring bar and bore it to final diameter, which will be 4.8mm. As I do this, I'm being nice and careful not to bore too deep, as I don't want to touch the rifling in the end of the barrel. With that done, the final thing to do on the transfer port was just put our internal O-ring groove in. I'm doing this using an internal grooving tool, just creating a 1.6mm wide groove, about 7.3mm in diameter. The O-ring that goes in this groove is our transfer port O-ring, and this O-ring is 4.3mm by 1.5mm. With that done, I'll take you over to the bench and show you the final components. Right then, so I'll just give you a quick look at the components now that they're all machined up, and I did do one or two things off camera which I very briefly want to go over. So starting off with the cylinder, the threads are cut in the end, and then the end has been blacked using some aluminium black. And overall I'm quite happy with how that came out. The threads are nice and close with the pairing part, which is the end cap here, and everything seals as it should. I have tested the rifle and there is no leaks or anything like that emanating from the end of the cylinder. So shortening the cylinder has been a complete success, and when the two parts are installed into one another, it looks something like that. So nice and factory. You probably wouldn't even know it had been machined unless you took the end cap out. But with that said, we can move on to the barrel. And the first thing we'll go over is the transfer port. So the only thing I did off camera here was just mill out the transfer port hole. I did this on the mill to create a rectangle transfer port hole, and that is 4mm long by 3mm wide. So a little bigger than the original part, but that was just so that with the shorter barrel we would not have any issues with power. So with our original longer barrel we were shooting around 780 feet per second using JSB 8.44 grain pellets, and when we swapped to the new shorter barrel that did only drop by about 20 feet per second down to 760 feet per second, again using the same 8.44 grain pellets. Luckily I didn't need to touch the reg or anything like that. I could just get the power back up to 780 feet per second just by using the hammer spring adjuster. The other thing I did off camera was cut the lead for the rifling. So I'm not quite sure how well the camera will pick it up, but there is a small chamfer cut into the end of the rifling to create a lead for the pellet. So I always cut my leads exactly the same no matter what barrel I'm using. And what I do is cut a 2-degree chamfer into the start of the rifling, with the major diameter of the taper being just over the skirt size of a pellet. This just ensures that a pellet is fed into the rifling nice and easily, and there is no major step or anything like that when we install a pellet into the rifling. If we take a quick look at that, you can see that there's no major damage to the pellet, and the head and skirt just have small witness marks from the rifling installed into the head. So there we have it, nice and clean. The lead is probably one of the most important features of the barrel, and if you have a bad lead, you're probably going to have an inaccurate barrel. My observations on the lead is that it should be nice and clean. There should be no burrs on the leading or trailing edge of the rifling, and the pellet should be fed nice and cleanly into it. I like my pellets to be fully seated within the rifling as the pellet probe pushes them into the barrel. Right then, so there's just one or two things I want to mention. To begin with, the rifle is no more or less accurate with the short barrel installed, although I will say it is much nicer to shoot in the new Sabre Tactical chassis. It fits me a lot better, and the platform overall is a lot more stable than the standard synthetic stock. The only things that let this rifle down are the magazines. If you single shot load it, it does some really nice groups at 50 yards. And the other thing I wanted to mention is the shot count. So we've cut roughly a fourth of the air cylinder off, as well as shortening the barrel and increasing the hammer spring tension, so the shot count has gone down slightly, but it's still not too bad. I'm getting between 130 and 140 shots per fill, which is still more than the factory rifle was getting out of the box. But with that said, that's pretty much going to do it for this particular video. So thank you very much for watching. I hope it's been interesting or useful, and I'll see you in the next one.